in this video, we're going to review a little bit how to graph an inequality, and then we're going to graph systems of inequalities in two variables. Now, an ordered pair of real numbers is a solution of an inequality if x and y in the substitution, x equals a and y equals b, satisfies the inequality. For example, the ordered pair 2, 5 is a solution of y is less than 2x plus 3 because 5 is less than 7. However, the ordered pair is not a solution because 8 is not less than 7. When we found all the solutions, we have solved the inequality. Now, the graph of an inequality in x and y consists of all pairs that are solutions of the inequality. The graph of an inequality involving two variables typically is a region of the coordinate plane. Now, in order to draw a graph of an inequality in two variables, generally you're going to graph the equation obtained by replacing the inequality sign by an equal sign. So that's going to be your boundary of your region. So you're going to solve the equation for y in order to graph it. Then you're going to check a point in each of the two regions of the plane determined by the graph of the equation. If the point satisfies the inequality, then shade the region containing the point. Super duper easy. You should have no trouble at all. So in example 1 here, we have to draw the inequality, state the boundary of the region. Well, my boundary will be y equals 2x plus 3. So that's what we're going to graph. 2x plus 3. So we go up 3, then up 2 over 1. Now I'm going to keep graphing this. Just put those points in there, make sure I have a nice straight line. Now, because it's greater than or equal to, generally because the equal to sign, we know that this is going to be a solid line straight through those points. Now, if there's just less than or greater than and not equal to it, it would be a dotted line. Now, we want to where it's greater than this. So what we're going to do, we're going to find a point. Well, if you choose a point anywhere on the y-axis where x equals 0, so if x is 0, let's say point 0, 4, right here, there's a point 0, 4. So if I put that in, is that in the region? Well, if x is 0 and y is 4, you have 4 is greater than or equal to 3. That is your region. So I'm going to shade up here. Now, if you choose a point 0, 0, which is right here, you end up getting 0 is greater than or equal to 3. That is not true, so that's why you don't shade below the line. Now, for part B, this is in standard form, so let's actually put it in y equals form. So y, actually 5y equals negative 2x plus 7. That means y will equal negative 2x, or 2/5 x. I'll rewrite that for you. Negative 2/5 x plus 7/5. And this is your boundary. Now, if I had to graph this, 7/5 is really 1 2/5, so it's going to be about there. Now, negative 2/5 for your slope is going to go down 2 to the right 5. Now again, this is less than or equal to, so it's going to be a line. Solid line, not dotted. Now it says less than or equal to, so if you choose a point 0, 0, then you go 0 less than or equal to 7. So the point 0, 0 is in your region. So you will shade below the line. Now the graph of linear equality, y is greater than or equal to ax plus b, just greater than ax plus b, less than or equal to ax plus b, or less than ax plus b, is a half plane. The graph of the line y equals ax plus b is the boundary of the region. We kind of talked about that already, but need to be said again. Now in example 2, we have to graph linear inequalities. Draw the inequality. Well, the line x equals 2, this is our boundary. X equals 2 is really a line going straight up and down, it's going to be a vertical line at x equals 2. Since it is greater than or equal to it, we're going to be a solid line. Now it says greater than 2, so since it says greater than 2, a number greater than 2 is say 3, that means our region goes this way. Now, if you look at the next one in B, it says y is less than -3. That means my boundary be y equals -3. That means it's actually going to be a dotted line. And y is equal to -3, and our boundary, anything less than -3, will be below it. Now, we'll put a dotted line there because it doesn't include y equals -3. So that's what happens there. Now our boundary for letter C will be x equals 4. And again, this is going to be a vertical line at x equals 4. As so. Now it says less than or equal to -4. That means I'm going to shade this way because anything less than -4 gets shaded this way. Now moving on to example 3, now we have a quadratic inequality. So first things first, we have to graph x squared minus 3. Well, x squared minus 3 has a y-intercept of -3. And then basically it's going to go, you're going to graph your parabola, pretending this is the new origin. So 2 So that's our parabola right there. It's the x squared function pushed down 3. Now it says greater than that. Well, let's choose a point on the inside. Let's choose the origin. So if I choose 0, 0 is greater than or equal to -3. So that actually is where our region is. Now if we do the same thing here, y is less than x squared plus 1. X squared plus 1 will look like this. And actually, because it's just less than, it's going to be a dotted parabola. Now it says it's less than that. Well, let's check some regions. Again, let's check the origin here. Nice, easy one to put in. So 0 for y, 0 for x. That means 0 is less than 1. That means you're going to shade out here, outside your parabola. Now, the next video, we're going to talk about systems of inequalities.